Hello everyone. Today we are going to discuss Biot Savart Law. It deals with magnetostatics. What is magnetostatics? If any charged particle is in motion, it will produce magnetic field in its surrounding. Okay. If we consider a filament and if a steady current is flowing through it, then it will produce magnetic field in its surrounding. And the problems associated with this magnetic field comes under the heading magnetostatics. Biot Savart law gives the magnetic field intensity at a point due to this current carrying filament. Okay, so let us consider a filament. Okay, let I is the current flowing through the filament. Okay. Let us consider a small length dl. If it has to be written in the vector form, then let us write it as dl bar. dl bar is the differential length element, or it is also termed as displacement length vector. Okay, this is nothing but the distance dl. If it has to be written in the vector form, then we write it as dl bar, and it is termed as displacement length vector. If I is the current flowing through this displacement length vector, then I dl is the differential current element. Yes, I is the current flowing through the filament. dl bar is the displacement length vector. Displacement length vector. Okay, and IDL is termed as differential current element. Differential current element. Now let us consider point P at a distance r from this displacement length vector. Okay, if the coordinates of point P are 0, 0, suppose, then I can write this in the vector form as r, a, r. Okay, where AR is the unit vector directed from the source point to the field point. Okay, yes, point P is the point at which the magnetic field intensity is to be determined. So let DH bar be the magnetic field intensity, magnetic field intensity at point P, okay, at point P due to current element I, D, L. Okay, so point P is the point at which magnetic field intensity is to be determined. Okay, and DH bar is the magnetic field intensity at point P due to the current element I, D, L. Now, if this is displacement length vector dl bar and this is unit vector AR, okay, then let theta be the angle between them. So I can also draw this dl bar and this will be theta. Okay. Now, according to Biot Savart law, the magnetic field intensity at a point dH bar is directly proportional to the current element IDL, and sine of the angle between the length displacement length vector dl bar and unit vector AR, that is sine theta, and it is inversely proportional to square of the distance between source point and the field point. Okay, so I can further simplify this equation as dH bar is equal to K dl sine theta upon r squared, where K is taken as the proportionality constant and its value is taken as 1 upon 4 pi. Okay, so I can write this as dH bar is equals to I dl sine theta upon 4 pi r square. Okay, I can also write this equation in this form. dH bar is equals to I dl bar cross unit vector AR upon 4 pi r square. Yes, we know that if we consider any two vectors, vector A and vector B, okay, and theta is the angle between them, then vector A cross vector B is equals to mod of A into mod of B sine of angle between them. So similarly, here we have considered the displacement length vector dl bar and unit vector AR, and cross product between them gives us magnitude of dl bar into magnitude of AR, which is equal to 1 into sine of angle between them, that is sine theta. Now, the total magnetic field, okay, the total magnetic field due to this current carrying filament at point P can be given by integrating above equation, that is H bar is equals to integral of I dl cross AR upon 4 pi r square. So this is the final equation. It gives the magnetic field intensity at point P due to the current carrying filament. Okay, so this is the final equation. Thank you.